Good morning. It's Wednesday, September 2nd. Let me turn down my music. I have it playing in the background, I think. All right, so what are we doing today? Well, what we're going to do is we're going to take a look at a few of the problems from the homework. And it's not due till tonight. And maybe there are quite a few questions about the book and, where to get to it and things like that. Well, so if you're looking at the online book, of course, it's going to be similar. It just, you don't have it in your hands. But there's a section that says tools of geometry, and right there, tools of geometry, and that's section 1.1. Okay, so every book unit is broken into modules. And so we are doing module 1, section 1. And then if you look at the bottom of the center of the page, it actually has a number. So you can see that right there. That's page number 4. And that's like a pre-quiz. And then we had you start on page number 5, which is segment length and midpoint. So there's a couple things in segment 5 that we didn't get a really chance to talk about. So I'm going to take some time today and I'm going to talk about those. First of all, take some notes. As I talk here, it'd be good to have some notes so you got some things. Let's just define a few things. You should have written these down already. But what is a point? A point is just it's just kind of a place in space. If you guys were here, I would tell you just to put your fingers together. That's a point. It's just a point. Now, there's an infinite amount, so this is kind of interesting. But if I take a little circle and I color this in, there's an infinite amount of points within that dot. And so you can't. Doesn't really have a measure. There's not a thickness to it. There's not depth. It's just represented. Usually, it's represented with a capital letter. We name it point P. We've talked about a line, but just as a definition, it just takes 2 points to name a line. 2 points. So, and again, we use 2 letters, and then we put like an arrow over top of that. Okay, and so that's called a line. And then another one that they have is a plane. Now, it says 2 points here. Now, I'm going to throw a new word out there. It's called non-collinear. It means they're not in a line. So many times a plane is represented like a parallelogram. So that looks like a plane. And it just means that there's 3 points. They're not lined up. And so we would name that. You can name it a couple ways, but most of the time it's plane. And you use the 3 points that are not in the same line. So if I go A, B, C, this would be called ABC, plane ABC. Now, you can just use, like if you have a picture like this, and let's say you put a Z down here, it can just be plane Z. So they use 2 different types, and that's how we name what a plane is. So we have a point, a line, and a plane. They keep going. They talk about a line segment, which just means it has 2 endpoints. This is review, something we've already talked about. They talk about array, which is the combination. Okay, so it's got an endpoint here. This would be AB. Now, when you name it a segment, it looks like that. When you have an array, that's AB. You just put like a arrow on top with an endpoint. Okay, so if it goes the other way, then you would just name it the other way. So let's say it looks like this. DE, it would be DE. Because the arrow is going through, it's continuing on. So now, again, it's going on forever, and so that's what the arrows represent. Endpoint means it stops. All right, now that should be enough for you to answer a lot of the questions that they have. Now, segment addition postulate and angle addition postulate, we haven't necessarily talked about them specifically um, as postulates, but we did discuss briefly. Okay, what the segment addition postulate says is, now this is on page 7, it says if you have a segment with a point on the inside of that segment, so we'll say it looks like this, then we know if we take the smaller segment and we add to it the other smaller segment, then the length will equal the full segment. So if this is a 5 and this is a 3, then we know that from here to here is an 8. That's called the segment addition postulate. And it's also true if you subtract away. So if I would have a problem like looks like this, that I know that the whole thing is 23 and that this is 9, well then I know that that's 14. So it works both ways. Okay, all right. Then talk a little bit about constructions. I think we're good. There's one other thing, one big thing I want to talk about with you in this time here is, well, before we get to the big thing, let's do the angle addition postulate. Angle addition postulate is very similar to the segment addition postulate. If I take doesn't matter if it's an acute or an obtuse angle, there's an acute. And if I were to name that angle, now remember, when I name an angle, I've probably talked about this too much, but this right here has to be the vertex. The middle term, the middle letter is always the vertex. Okay? All right, so now that we know that, so let me come back and recreate that. So if I have A, B, and C, and I have another segment or ray that goes out of the vertex. It's called, put a D there. Then I know that this equation is true. I can set this up. That angle ABD, that's this angle right here, if I shade it in, that's that angle, plus angle DBC, that's this angle, if I add those two together, then they're equal to the larger angle, which is angle ABC. Some people struggle with seeing that there are 3 angles there. And there are two smaller ones and then the larger one, which is the addition. It's very similar to the segment addition postulate. So if I said that this was 40 degrees and this was 25 degrees, so if this is 40 and this is 25, then we know that the entire angle is 65 degrees. You're going to see things like that on your homework. All right, so like I said, there's one other thing, major thing that I want to talk about, and that's the distance formula. And then I'm going to close this video and upload it, and then I'm going to come back and do another video with some homework. All right, so let's talk about the distance formula. Now, the distance formula, you may remember from algebra or from whenever you talked about it, but it finds the distance between 2 points. Okay, it finds the distance between 2 points. Now, in geometry, we graph all the time, but this is going to be used throughout the entire school year. Okay, so we're finding the distance between 2 points. All right, so quick reminder, we have an X and a Y, ordered pair. That's a coordinate plane. This is called the origin. Okay, and so if I have the coordinate 3, -2. I go over 1, 2, 3, and I go down 2. And that coordinate is 3, -2. Over 1, 2, 3, down 2. Okay, all right. You need to know those basics in order to do the distance formula. Okay, well, the distance formula, it's also in your book. It's on page, looks like 9, page 9. It says this, that the distance between 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. Now, what do those little sub numbers mean? These numbers right here, what do they mean? Really nothing. They're just a way to distinguish between one point and another point. So basically, this is just one point, and this is another point. That's all those sub numbers mean. Okay. Now they're different. They distinguish. They're different, and so they matter. The order of them matters. You know, where you put them in the formula, they matter. So here's the formula, and it's d is equal to the square root. Remember square root? Remember the square root of 49 is equal to 7. Remember that? Okay. So then you just take one, and it doesn't really matter which one, but we're going to start with x sub 2. And you subtract away x sub 1. We're going to square it. And then we add y sub 2 minus y sub 1. We're going to square that. Now, later we're going to figure out where is this derived from? Where does this come from? Because it's actually related to slope. It's related to Pythagorean theorem. There's just a lot of different ways that you can find it. So that's the formula for the distance formula. And so you just basically you take the difference. You take the difference of the x values, and I'll say this a lot, of x values, and you square it, and you add to that the difference. Difference means subtraction. Difference of the y values. Okay, and you add to that, and then you take the square root of the entire thing. Difference of x values, square it. Difference of y values, square it. Take the square root. Okay? All right. I'm going to pause this, or I'm going to stop this, because that's pretty much the notes. Well, let me make sure. Well, they do talk about a midpoint. We've talked about that. Let me say that before I finish. So hopefully you didn't turn it off. But if I want to find the midpoint, it sounds just like the word. The midpoint sounds just like what it's. I mean, it means exactly what it sounds like. So if I have a segment, would the midpoint be about here? No. Would it be about here? No. It's going to be right in the middle. And so that is the middle of the segment, and therefore is what we would call the midpoint. Okay. Now, if I'm trying to find the midpoint that is graphed, okay, well, if this is an x1, y1, and this is an x2, y2, so in other words, they're graphed on a coordinate plane. To find this midpoint, all you do is add them, divide by 2. You take x plus 1, x sub 1 plus x sub 2 divided by 2, and you do the same thing with the y. And that's the midpoint. Okay? All right. We'll look at a couple examples. All right, let me stop and I'll upload this.